The speed of Earth rotation about its axis is omega. If its speed is increased to x times to make the effective acceleration due to gravity equal to 0 at the equator, then the value of x is. So we know that due to the rotation of Earth, there will be a centrifugal force is acting. So we can find out the value of acceleration due to gravity at an angle theta by using, or at a latitude theta, by using this equation g0 minus r omega square into cos square theta. We are writing this equation based on this concept that if Earth is rotating about its axis with an angular velocity that is equal to omega, due to the centrifugal force, acceleration due to gravity will change. So if you want to find out the value of acceleration due to gravity at a point P, which is at a latitude theta, or which is making an angle theta with respect to the equatorial line, then we can use this equation. Now at equator the value of theta will be equal to 0, and at pole the value of theta is equal to 90 degree. Now you can observe that in question it is given that the speed of Earth rotation about its axis is omega. They are talking about the angular velocity omega. The speed is increased to x times to make the effective acceleration due to gravity equal to 0 at equator. So we can write at equator this theta is equal to 0. So cos 0 is equal to 1. So we can write the value of g at an angle theta is equal to g0 minus r omega square. So that we increase the value of omega from omega to a value, let's say omega dash. So now the omega becomes omega dash, so that the value of its angular velocity, so that its net acceleration becomes equal to 0. So you can find out the value of omega over here. So you can write this g0 should be equal to r omega square. So the value of this omega should be equal to under root of g0 divided by r. So we can write this under root of the value of g0, you can approximately take it as 10 divided by r is radius of Earth, that is around 6400 kilometer. So 6400 into 10 raised to 3 meter. So this 10 and 110 over here get cancelled. So we can write this as 1 divided by 64 into 10 raised to 4. So root of 1 we can take it as 1, 64 root which we can take it as 8 into 10 raised to 2. Or you can write the value of omega is equal to 1 divided by 800, or the value of omega dash. So we just calculate the value of current value of omega, let's say omega dash. So the value of angular velocity now is nothing but 1 divided by 800. Now initial angular velocity was, we know that Earth is rotating about its axis, or Earth is completing one full rotation in a time of 24 hours. So initial value of omega we can take it as nothing but 2 pi divided by its time period t, which is 24 hours. So just 2 pi divided by 24 into 60 into 60. So this was the initial value of omega. Now it is in question, it is given that final value of omega, which is omega dash, is x times of initial value of omega. So Rm is to find out the value of x. So we can write it as omega dash divided by omega. The value of omega dash is 1 by 800, and the value of omega is 2 pi divided by 24 into 60 into 60, 24 hours. So 24 into 60 minutes into 60 seconds. So we can cancel this 0 over here and 1 0 over here, and we know that 8 3s are 24. So it will be something like x is equal to, we can take it as 3 into 6 divided by 2 pi. Now you can cancel 1 2 and this over here, it is going to be 3 into 3 9 into 6, which we can take it as 54. So it will be nearer to 54 by pi. So we can find out what about the approximate value over here. This is 54 divided by nearer to 3 pi, we can take it as 3.14. We'll get nearer to 17.19, or we can approximately take it as 70.